Okay, tell me, are the voice and screen clear or okay? Are the voice and screen clear? All okay? Yes, fine. Thank you. Do it. Do it. Find out total energy of the system. First of all, find out total energy of the system and then write that total energy is positive means what? Greater than 0. So you will bring this sign and automatically other things shall get cancelled and this shall be automatically proved. Do it. After that, reply me in the chat box small d for done. Hmm. Do it. Done. Done. Hmm. Anyone? Do it. Done. Good. Everyone do it. I reply me. U of the system. Let us call this as first. Let us call this as second charge. Let us call this as third charge. Okay, sir. So let us bring the first charge 0. Let us bring the second charge in the field of first. K. Q1 is capital Q. Q2 is 2Q. K Q1 Q2 upon R12. R12 is small a. Plus we have got the second charge in the field of first. Now we have to bring third charge in the field of first and third charge in the field of second because 1 and 2 are already present in the system. So 3 will interact with both of these. So K, Q1 is Q, Q2 is minus Q divided by R13, K Q1 Q3 upon R13. R13 is small a plus 3 is to be brought in the field of second. So K Q2, Q2 is 2Q, Q3 is simply minus Q divided by R23. Distance between 2 and 3 is small a. Sir, what can be taken as common? K capital Q upon small a. K capital Q upon small a. K capital Q upon small a can be taken as common. Into bracket. This is U of the system. This is U of the system. K capital Q upon small a. K capital Q upon small a. K capital Q upon small a. Common. What remains? 2 capital Q minus Q 2 capital Q. No. K capital Q upon small a already common. 2 minus Q remains as it is. K capital Q upon small a common. What remains? 2 minus Q means minus 2Q. This is internal energy of the system. Two Q as it is. Minus Q minus 2Q minus 3Q. This is the internal energy of the system. What is given? U of the system is a positive value, means it must be more than 0. And U of the system can be replaced by this. Don't get confused. You have to first write U of the system greater than 0. Do not bring any less than greater than sign in this equation. Write the inequality here and then put the values. Okay. I do not want any kind of confusion here. Don't bring any of the less than greater than sign here. First find out U of the system. Then write the inequality. U of the system more than 0. Inequality means more than less than. KQ upon A is the replacement for Q of the U of the system. kq upon a in the bracket 2q minus 3q. This value is more than 0. Okay, 0 into a 0, so a on the right hand side, kq 0 upon kq, so this on the right hand side will become 0, this on the right hand side will become 0. Okay, now this 3q on the right hand side minus 3q on the right hand side will become plus 3q, or no need to write plus. Reply me in the chat box, clear and written. CW. Good. Now you shall simply say that, sir, now these kinds of questions are very simple questions. We are just verifying what are the different types. So this is a type of question. We are just verifying the types. A new type of question might be generated in the exam, but the fundamentals are going to remain the same. K, Q1, Q2 upon R1, Q is the fundamental equation. That's it. Fine. Do you know the rules of inequality? Let's say A and B. It is given that A is more than B. Then reply me in the chat box. Minus A will be what compared with minus B? More than or less than? M or L? I multiplied both the sides by minus 1. Then inequality remains same or changes? More than, less than? M or L? That you need to know here, because now comes the inequality. Everyone, very simple task. What we can do, we can take its complementary example. 3 more than 2. Then minus 3 what compared with minus 2? Oh, sir, minus 2 is more. Means inequality changes if you multiply by minus sign. Inequality changes if you multiply by minus sign. Means if A is more than B, then minus A will be less than minus B. Minus A will be less than minus B. If you multiply on both the sides by minus sign, inequality changes, greater than, less than. Okay, this rule you have to remember. Other rules same as equality. You can take this on the right side. You can divide this on the right side. That remains. That will not change the sign of equality. Direction of equality. That will not change the direction of inequality. If you multiply the given equation by the minus sign, then the direction of inequality changes. Initially it was more than, now it will become less than. Okay, fine. Hope that is clear to all of you. Next question. Question number 13. Solve it along with me. Let me read the question. You try to extract the data. For the given figure, charge Q1 equal to some value and Q2 equal to some value. Okay. Q1 is given, Q2 is given. A charge Q3 equal to some value is taken along the arc of the circle from the point C to D. Okay. Then the potential energy of Q3 is decreased by what percent? For the given figure. Arc of the circle C, arc of the circle D. Point A, point B, point C, point D. Charge Q1, charge Q2, charge Q3. Q3 is being moved from point C to point D on the arc of the circle. This distance 60 centimeter. This distance 80 centimeter. This distance 80 centimeter. 6, 8, 10, 60, 80, 100. 6, 8, 10. That triangle, Pythagoras triangle. 3, 4, 5. 3, 4, 5. If 3, 4, and 5 is the Pythagoras triangle, you can double all the sides of the triangle. You can multiply all the sides by 10. So side 60, side 100, so it will become, side 60, side 80. 60, 80, 100. 6, 8, 10. 3, 4, 5. 60, 80, 100. The distances are given in centimeter. We need to convert them into meter. Okay, sir. Fine. No problem. Now the radius of the circle will be what? Reply in the chat box. Arc of the circle. Q3 is being moved on the arc of the circle. Then what is the radius of the circle? This is the center of the circle. Now look at the diagram carefully and reply in the chat box. Because that is what you need to figure out first. Yes, sir. That is equal to 80 centimeter. Perfect. That is equal to 80 centimeter. Fine. This much is 60 centimeter. This much will be 20 centimeter. Total will be 80 centimeter. Write down. Q3 moved on the arc of the circle. Q3 moved on the arc of the circle. Arc of the circle. What is asked? Then the potential energy of the charge Q3, not the system, of the charge Q3 on the arc of the circle from point C to point B, then potential energy of Q3 decreases by what percent? Okay. Decreases by what percentage? Decreases by what percentage? Fine. Q3 is initially here. Q1, Q3, Q1, Q2, Q3 values are already given to us. Write those down. 2 into 10 raised to minus 8. Next, minus 0.4 into 10 raised to minus 8. Then Q3 is 0.2 into 10 raised to minus 8. Fine. Of course, Coulomb. All right. Next, what we have to do? We have to find out percentage decrease. Fine. Percentage decrease in the potential energy of Q3. Percentage decrease is equal to decrease. We want to calculate decrease. Decrease means initial minus final. Percentage change विचारला असता तर if we were asked percentage change, we would have done final minus initial. But right now they are asking percentage decrease. So initial energy of third charge minus final energy of the third charge divided by initial energy of the third charge multiplied by 100. This is the value of decreasing the potential energy of the third charge. Potential energy of third charge. So decrease upon original into 100 will give you percentage decrease. Decrease upon original into 100 will give you percentage decrease. Okay, fine, sir. So we have to find out initial energy of the third charge. We have to find out final energy of the third charge, and we simply have to put the values. Okay, sir. Let's do it. Initial energy of the third charge. Initial energy of the third charge. Third charge initially was at point C. It is in the field of A. It is in the field of B. What is the interaction energy of third charge with A and third charge with B? Or with third charge with first charge and third charge with second charge. K. Q1, Q3 upon R13. Q1 is some value is given to us. Q3 some value is given to us. R13 is 80 centimeter. R13 is 80 centimeter. 80 into 10 raised to minus 2, write it down. Okay. Plus Q3 in the field of B. K Q3 Q2 upon R32 or Q2 Q3 upon R23. Q2 some value is already given, let it be. Q3 some value is already given, let it be. Upon R2 and 3, R2 3. That distance is 100 centimeter. So 100 into 10 raised to minus 2 centimeter 10 raised to minus 2. Fine. So this is going to be the initial energy of third charge. That's it. You are not asked energy of the system. Is that clear? Replying in the chat box. You have to very carefully read the question. Otherwise, first charge, second charge, third charge, and we find the energy of the system. That will give us, that might give us wrong answer. Might give us, not always. Okay, one message was there. Let me read that. Sir, ultimately there is division, so unit won't matter. Why? Yes, ultimately there is going to be division, so unit won't matter. Perfect. Energy upon energy, so unit here will not matter. Perfect. That you can definitely do. Energy of third charge in the final situation. Finally, this third charge is not at point C. It is at point D. So do it. Point D, point A. Interaction. Means third charge is here. First charge is here. K. Q1. Q1 is the first charge. Q3 is the third charge. Q1, Q3 upon R13. 60 plus 20, 80. Centimeter. So third charge here, first charge here. Now third charge will also interact with the second charge. K, Q2, Q3, Q2, Q3 upon R23. That is 20. Will you do this on your own? K value 9 into 10 raised to 9. K value 9 into 10 raised to 9. Q1, Q2, Q3, all the values are given. Okay, you have to be best. You have to be patient while calculating all these things, and after that you have to correctly calculate the things after putting in this formula. Okay, so K value is 9 into 10 raised to 9. Q1, Q2 values are already given. We do not have any problem with these. Okay, I want all of you to do this. Okay, now don't do absolute calculation. Do not do absolute calculation. Take what are the things which can be taken common from this. Check what are the things which can be taken common from this. Cancel out the common things, because ultimately it is going to be the subtraction here in the numerator and division. Subtraction and division. Take the things common. Divide it. Get the common things cancelled, and then go for the calculation. I am not asking you to calculate U initial. Don't calculate exact value of U initial. Don't calculate exact value of U final. Don't do that. Try to take common. Then put the values here. Get rid of the common values and then calculate. Today's calculation task. You have to submit this on the group. Okay. You have to submit this on the group. Yesterday also one calculation task was given to you that I want you to submit. Is this question clear to all of you? Replying in the chat box. What was asked and how to calculate it, and get yourself convinced that here after this step we can calculate on our own. Get yourself convinced and do that calculation and submit on the group, and check with the others calculation, check with the calculation given in the module. Only then you will develop yourself for the calculation. Okay. If you want to learn the swimming, you cannot just observe it. Okay. तुम्हाला जर स्विमिंग शिकायचं असेल तर तुम्ही फक्त बघून, स्विमिंगचा व्हिडिओ बघून कधीही स्विमिंग येणार नाही. ड्रायव्हिंगचा व्हिडिओ बघून कधीही ड्रायव्हिंग येणार नाही. हे कॅल्क्युलेशन एकदा स्वतः करावं लागेल. एकदा त्याच्यावरती होल्ड आला मग फक्त बघत राहा. मग काय अडचण नाही. पहिल्यांदा ड्रायव्हिंग शिका, स्टंट आपण नंतर मारू. स्टंट साठी व्हिडिओ बघता येईल. ड्रायव्हिंग साठी कसा व्हिडिओ बघा? ड्रायव्हिंग साठी स्वतः ट्राय करावं लागेल. ओके, पहिल्यांदा एकदा कॅल्क्युलेशन वरती होल्ड घ्या, कॅल्क्युलेशन स्वतः करा. या वीक मध्ये हेच करायचं आहे. दिस वीक विल बी अगेन डेडिकेटेड टू कॅल्क्युलेशन्स. Get confidence on the calculation. Once you get the confidence on the calculation, then just by looking at the method, how the question is solved, you will improve your knowledge. इथं आता मग परत परत सारखं कॅल्क्युलेशनची गरज लागणार, पण या वीक मध्ये भरपूर कॅल्क्युलेशन करायचं. आणि याच्यानंतर afterwards you will be simply looking at the question. Okay, this is how it is going to be solved. Okay, लिहिलं, डोक्यामध्ये ठेवलं, दॅट्स इट. आता त्याचं कॅल्क्युलेशन परत करायची गरज राहणार नाही. पण कॅल्क्युलेशन वरती पहिल्यांदा होल्ड घ्या. या चॅप्टर मधल्या कॅल्क्युलेशन वरती होल्ड घ्या. क्वेश्चन सिंपल आहे, कॅल्क्युलेट करायला लावतोय. सो इट इज गोइंग टू टेक 1 or 2 minutes. सो ट्राय टू रिड्यूस दॅट टाइम. ओके, 4 मार्क कुठेही गेले नाहीये, पण कॅल्क्युलेशन पण करावं लागतं. ओके, फाइन. नेक्स्ट, क्वेश्चन नंबर 14. Some electric lines of force are shown in the figure for point A and B. Okay, this is very easy question. Why this question is here? Some electric field lines are shown like this. Here they have written point A. Here they have written point B. Compare the electric field at point A and B. Option A, EA, EB more than. Option B, less than. Okay, this is why it is here. VA means potential. Electric potential we have not learned yet. Okay, electric potential we have not learned yet. Okay, so right now this question we cannot solve for electric potential, but that we can solve for electric field. Electric potential we will learn, and then we will solve the same question back again. Okay, you just remind me. Between 1 and 2, which is the correct answer? Number of lines of force in the unit area. Number of lines of force in the unit area. Here lines are crowded, their field will be more. That's it. Option number A correct. Of course, या दोन्ही पैकी काहीतरी एक पण करेक्ट असणार आहे. Okay, of course, out of these two, one is going to be correct, but that right now we cannot answer. Okay, keep it as it is. You just remind me after learning the concept of electric potential. Okay, next. So they give the question here. Okay, for the electric potential, we solve it later. Question number 15. Question number 15. Let me read the question. If a charge is released in the electric field, will it follow line of force? Oh. If, write down. If the charge is released, if the charge is released, release means not thrown, simply released. You have to initially hold the charge, and now you have to release it. You have not to throw the charge. You are not asked to throw the charge. You have to simply release the charge. So hold the charge in the electric field. Now just release it. If the charge is released in the electric field, will it follow lines of force? Will it follow lines of force? Fine. This is the question. Now try to understand. These are the fundamental concepts. There are basically two cases. Okay, this is a very typical question. This is generally asked. Okay, it is generally asked in almost every book. You will find this question. Let us take electric field lines like this. Now, what is the meaning of this kind of electric field? There is a particular name. Can you recall that? Equidistance. Distance between these two, distance between these two is same. Equidistant parallel straight lines represent which kind of electric field? It has particular name. Equidistant parallel electric field represent which kind of electric field? Very good, Prasad. Advait. It is called as what, guys? Sir, it is called as uniform electric field. Uniform electric field means it has same magnitude and same direction at each and every point. Okay. So, sir, if the point charge, let's say Q, is placed here, is right now placed here, now we are going to release it. If I release that charge, there will be a constant force which is acting on this charge, which will be equal to EQ. Which will be equal to EQ. Initially, this charge was at rest. Now we released it. Always during the motion also, electric field at each and every point it is EQ. Electric field at each and every point it is EQ. So it is going to be a electric field at each and every point is E, and the force acting on the particle at each and every instance is EQ. It is always rightward. So initially the particle was at rest. Now a constant force EQ always acts on it. So it will simply go on accelerating like this. It will simply go on accelerating like this. So it will follow the line of force forever and ever. It will follow the line of force. So this case, for above case, when charge is released, it will follow line of force. Charge is released, it will follow line of force. It will follow line of force. Fine. This is a uniform electric field. Okay. Write down. For above case means, which is this case? This is uniform electric field. This is the case of uniform electric field. This is the case of uniform electric field. And the second case will be obviously non-uniform electric field. Non-uniform electric field. Here it is already shown. Non-uniform electric field means at different points, electric field has different directions, all different magnitudes, or magnitude and direction both different. Okay. Non-uniform electric field. This is a non-uniform electric field. Okay. And let's say we release the charge here at this point. Let's say we release the charge here at this point. Initially charge is here, we just released it. Initially the force will be acting like this. Okay. A very small distance equal to dr, it will travel in this direction, because initially it had no motion, but now the motion has started. So now the velocity is like this. Let's say the particle, after traveling a small distance, comes at this point. Okay, sir. Fine. Now at this point, its velocity is like this. And initially the force acted like this. Okay, after a very small time interval dt, this motion to the time interval equal to, let's say, dt. After that, its velocity will be in this direction. But now, here at this point, we have to check what is the direction of electric field. So let's say at that point, the line of force is something like this. So this is at this point, the tangent will give us the direction of electric field. Now this is going to be the new force acting on the particle. Okay. Now you people tell me. Initially, it was on this line of force. Initially, the particle was on this line of force. Now this force is on another line of force. This velocity is on some on other direction. Okay, a velocity ची काहीतरी वेगळीच direction है. This velocity has some different direction. This force is acting tangent to a new line of force. Initially, the force was on this line of force. Okay. Now, because of this force, the particle will change its magnitude and the direction of velocity. So now the particle will change its path, and it might follow path like this. Okay. So particle started at this point and it followed some different path, cutting many of the electric field lines. Cutting many of the electric field lines. So it didn't move on the same electric field line. It is a simple thought that in non-uniform electric field, particle will not move on the same electric field, same line of force, because initially the particle was on this line of force, but this line of force gives the force tangent to itself. Now the particle will move outside this line of force. त्याला लाईन ऑफ फोर्स सोडली ना, कारण फोर्स कसा टँजंट संपला विषय. इथंच आम्हाला लक्षात यायला पाहिजे की particle will not travel along the same line of force. It will keep on changing the line of forces. Small c replying in the chat box. In non-uniform electric field, charge will not follow. Charge when released, charge when released will not follow line of force. Charge will not follow the line of force. Okay, trajectory is going to be some different. It's a typical question. You have to know the concept of uniform and non-uniform electric. That's it. Up to this point, is that clear? Everyone replying in the chat box? All okay? Up to this point, everything clear? Just a second. Just give me a second. All right. Up to this point, everything clear and written? The things taught and the questions solved in today's lecture? Good, very good. Fine. Now the next concept comes, that is electric potential. Okay, electric field concept we have already covered. Potential energy example we have covered. Now the new concept, electric potential, is the new concept. Electric potential energy we have learned. Now we are learning electric potential. First we have to learn potential energy. Now we have to learn potential. Okay, sir. What is potential energy? It is work done to bring the it is work done to bring the charge from infinity to given position. It is work done to bring the charges or the charge from infinity to given point in the system. That is the potential energy. Then what is potential? It is potential energy per unit charge. It is potential energy per unit charge. Just like initially we know what is force between 2 point charges. Then to find out electric field, what we did? We did force per unit positive charge. Okay, electric field is force per unit positive charge. Okay, so first learn the force, then define the electric field. First learn the force between the 2 point charges, then define the electric field as force per unit charge. Now learn the potential energy of the system or the charges, and then define the potential as potential energy per unit charge. Potential energy per unit charge. Electric field is a vector quantity. Electric field is a vector quantity. Potential energy is a scalar value. It can be positive, negative, zero, but it is a scalar value. It has no sense of direction. Charge can be positive, negative, zero, but still it has no sense of direction. Plus 3 coulomb in rightward direction has no meaning. Potential energy is a scalar value. Charge is a scalar value. Potential is a scalar value. So electric field is vector. Electric potential is scalar. Electric potential is scalar. Potential energy, all types of energy, work done, all those are scalar values. Yes, that we know, sir. Fine. So initially force is defined, force per unit charge, electric field is defined. Now now potential energy will be defined, and potential energy per unit charge will give you potential. Electric field is a vector and its value is to be found at given point. Its value is to be found at given point. Electric field at given point. Just like that, potential at given point. Electric field at given point. Potential at given point. Up to this, is that clear? Scalar, vector, and at given point. Who is scalar? Who is vector? Electric field at given point. Potential at given point. Force per unit charge, electric field. Potential energy per unit charge, potential. Okay, so potential at given point calculate करायचं असेल. Okay, fine. Okay, now to find out potential, we need potential energy. To find out potential energy, there must be existence of the force, and for the existence of the force, there must be electric field. So electric field पहिल्यांदा असली पाहिजे. There must be some electric field in the space, and in that electric field, there will be some point at which you will be asked to find out the potential. Okay, sir. Next, write down definition. At a given point in the field, at a given point in which field? In electric field. At a given point in electric field, okay, sir. At a given point in the electric field, electric potential is defined as electric potential is defined as electric potential is defined as. So we will not ask why. It is defined as for convenience. Okay, it is defined as the interaction energy of a unit positive charge. Interaction energy of unit positive charge. Let it be. We will simplify it. Don't worry. Just write it down. We have only 1 minute left in our. Fine. Just write this down. Or what we can do is this. Different forms of the same equation we can write. Okay. आता जेवढं होतं तेवढं आपण लिहून घेऊ. बाकी सगळं राहिलेलं बाळांनो नेक्स्ट लेक्चरला लिहू. Okay. Fine. Just try to write down along with me. We will discuss and write down the remaining things, whichever things remain, in the next lecture. Just don't worry. Electric potential, or simply potential. Electric potential at a given point. At a given point in the electric field. In the electric field. In the electric field is what is that? It is interaction energy of unit positive charge. Unit positive charge. Complete the set. It is interaction energy of unit positive charge. U upon Q. Okay. If you have charge equal to 1 coulomb, no problem. U will be equal to V. Numerically, U will be equal to V. But if you do not have 1 coulomb, if you have 5 coulomb, काय नाही. 5 coulomb ची interaction energy divided by 5 coulomb. So that you will get interaction energy of 1 coulomb. If you have 5 coulomb charge, take 5 coulomb. Find out interaction energy of 5 coulomb charge.